Hello, this is Dr. Ayashola Ogundele, Astronautics for Exploit. In-orbit construction of space solar power system. The focus points of my presentation are as follows. Space solar power, a new source of clean energy. The need for space solar power. Space solar power requirements. An in-orbit construction of space solar power system. Over many decades, the industrial economy, an economy centered around the production of tangible finished goods and infrastructure, and being driven by the burning of fossil fuels, such as non-renewable energy sources, for example, coal, coal products, natural gas, derived gas, crude oil, petroleum products, and non-renewable waste, has led to the degradation of the Earth's environment. A large amount of carbon dioxide, the Earth's most important greenhouse gas, is released into the Earth's atmosphere because of burning fossil fuels. Without carbon dioxide, Earth's natural greenhouse effect will be too weak to keep the average global surface temperature above freezing. By adding more carbon dioxide to the atmosphere, the natural greenhouse effect is being increasingly charged, leading to increase in global temperature. According to the research findings, in 2021, carbon dioxide alone was responsible for about two-thirds of the total heating influence of all human-produced greenhouse gases. Space solar power, limitless clean energy from space, with zero carbon emissions, which research findings show that can solve the global energy and greenhouse gas emissions problems, is presently receiving support based on lower launch costs, technological advancement, and interest in clean energy sources. Various plans are being undertaken to test and verify space solar power key technologies and capabilities, such as power generation, conversion, and transmission and building infrastructure on the ground for receiving energy transmissions. The technologies and infrastructure needed to be put in place for successful actualization of implementation of space solar power are in-orbit construction and operations of space solar power in large proportion, reduction in launch costs, and development of low-cost launch vehicles and efficient power transmission technology. Different space power system in-orbit construction approaches of using lunar and asteroid materials have been proposed. Grad Oned in 1970s proposed building the space power system in orbit with materials from the moon. Another proposal was to capture the asteroid Apophis into Earth orbit and convert it into 150 solar power satellites of 5 gigawatts, each of the larger asteroid 1999 AN10, which is about 50 times the size of Apophis, and large enough to build 7,500 5 gigawatt solar power satellites. Space solar power, a new source of clean energy. Presently, government space agencies and private space companies' attentions are shifting towards the space solar power implementation due to the need to find new sources of clean energy. Space solar power gathers energy from sunlight in space and transmits it wirelessly to the Earth. It has been forecasted that space solar power can solve our energy and greenhouse gas emissions problems. The picture here shows an artist's impression of space solar power system using laser transmission to beam solar power down to the Earth. Space solar power requirements. Research findings show that space solar power can provide large quantities of energy to every person on Earth with very little environmental impact. The solar energy available in space is literally billions of times greater than what we use today. The picture here shows illustration of solar collecting satellite. The need for space solar power. There are different needs for space solar power, and each of them is highlighted below. Space solar power does not emit greenhouse gases, in contrary to the oil, gas, ethanol, and coal plants. Space solar power does not compete for or depend upon increasing scarce freshwater resources, unlike as in the case of coal and nuclear plants. Space solar power does not compete for increasingly valuable farmland or depend on natural gas derived fertilizer, unlike as in the case of ethanol or biodiesel. Illustration of solar farms in space is shown in this picture. Other reasons for interest in space solar power are space solar power can be exported to virtually any place in the world, and its energy can be converted for local needs, such as manufacture of methanol. Space solar power can also be used for desalination of seawater. Space solar power can help to expand employment opportunities in solving the difficult problems of energy security and climate change. The picture here shows space-based solar power, which involves harvesting sunlight from Earth orbit and then beaming it down to the surface where it is needed. Other reasons for interest in space solar power are space solar power can provide a market large enough to develop the low space transportation system, which is required for its deployment. This, in turn, will also bring the resources of the solar system within economic reach. Space solar power will not produce hazardous waste, which needs to be stored and guarded for hundreds of years, unlike as in the case of nuclear power plants. The picture here shows space-based solar power. Space solar power requirements. The following requirements, such as technologies and infrastructure, are needed to be put in place for successful actualization of implementation of space solar power. In-orbit construction and operations of space solar power in large proportion. Reduce launch cost and development of low-cost launch vehicles. Easy and efficient power transmission. The picture here shows multi-rotary joint solar power satellite. Space solar power requirements of in-orbit construction and operations of space solar power in large proportion. In order to get enormous amount of solar energy, solar power satellites must be large with large solar arrays. Solar power satellites will be simpler in comparison to the International Space Station because it will consist of many identical parts. The picture here shows demonstration of beaming of electricity down to the Earth from satellites through microwaves. Reduce launch cost and development of low-cost launch vehicles, which is another space solar power requirement. Expendable launch vehicles have been truly expensive and at high launch rates may pose atmospheric pollution problems of their own. Cheaper reusable launch vehicles are under development by various private space companies. The picture here shows space-based solar power involving harvesting sunlight from Earth orbit and then beaming it down to the surface where it is needed. Easy and efficient power transmission is another requirement of space solar power. There is the need to embark on developing a solar power technology, which will have an efficient capability to transmit solar energy generated by the solar satellite to the Earth. A relatively small effort is also necessary to assess how to best transmit power from satellites to the Earth's surface with minimal environmental impact. The picture here shows a solar power satellite built from a mined asteroid. In-orbit construction of space solar power system. The key technologies. Presently, efforts are ongoing to test key technologies and on-orbit assembly models required by the space-based solar power. Space-based solar power test system. A space-based solar power test system planned to be demonstrated is aimed at testing and verifying capabilities such as power generation by the solar arrays, conversion, and transmission. The picture here shows artist's concept of a solar disk on top of a low Earth orbit to geostationary Earth orbit electrically powered space talk. Promotion of breakthrough technology. A space-based solar power test is planned to be designed to promote breakthroughs in space solar power system technologies. The CDN designed a 75-meter high-steel structure facility, which it calls the world's first full-link and full-system ground test system for space-based solar power. The picture here shows proposed space solar array SPS Alpha, the image and concept. Research into construction of kilometer-scale objects in orbit is ongoing. Such work could help to address the major challenge of assembling the giant arrays needed for solar power collection and transmission arrays. Gigawatt-scale baseload solar plant on a satellite is demonstrated on this picture. The in-orbit construction approach. Construction of space solar power system using lunar materials launched in orbit and construction of space solar power system using materials from asteroid. The picture here shows illustration of the idea of space-based solar power, a feasible and competitive renewable energy sources. Construction of space solar power system using lunar materials launched in orbit. Due to the expensive cost, Gerard O'Neill in the early 1970s proposed building the space solar power system in orbit with materials obtained from the moon, Earth's only natural satellite and the fifth largest satellite in the solar system, and the largest and most massive relative to its parent planet, with a diameter about 1/4 of that of the Earth. The picture here shows illustration of the SPS Alpha solar power satellite by means of arbitrarily large phased array system beaming energy. Construction of space solar system using lunar materials launched in orbit. Launch costs from the moon are potentially much lower than from the Earth due to the lower gravity and lack of atmospheric drag. 1980s space solar power system concept proposed relied less on human presence in space and more on partially self-replicating systems on the lunar surface under remote control of workers stationed on the Earth. The picture here shows space-based solar power satellite, a satellite that captures light from the sun and beam power to the Earth. Construction of space solar power system using lunar materials launched in orbit. Using raw materials from space will lessen the concern for low-mass designs and result in a better space solar power system being built. The low cost per pound of lunar materials and honest fusion will be supported by using lunar material to manufacture more facilities in orbit than just solar power satellites. The picture here shows solar power plant in space. Construction of space solar power system also involves the use of advanced techniques. Advanced techniques for launching from the moon may reduce the cost of building a solar power satellite from lunar materials. Some proposed techniques include the lunar mass driver and the lunar space elevator, first described by Jerome Pearson. It will require establishing silicon mining and solar cell manufacturing facilities on the moon. The picture here shows Cassiopeia Space-Based Solar Power Initiative. Construction of space solar power system using asteroid materials launched in orbit. Presently, efforts are ongoing by the space agencies and private space companies to mine asteroids in space. Using the mined asteroid will lead to about 95% reduction in launch costs. The picture here shows the Space Energy Initiative satellites designed to collect solar energy in space. One proposal is to capture the asteroid Apophis into Earth orbit and convert it into 150 solar power satellites of 5 gigawatts each, or the larger asteroid 1999 AN10, which is 50 times larger than the size of Apophis and large enough to build 7,500 5 gigawatt solar power satellites. The picture here shows solar power plant space station. For more information, contact Astronautics for Exploit. You've been watching and listening to In-Orbit Construction of Space Solar Power System, presented by Dr. Ayoshola Ogundele, Astronautics for Exploit, with the focus points: space solar power, a new source of clean energy, the need for space solar power requirements, and in-orbit construction of space solar power system. Thank you.